If you have manual gearbox problems, like gear stick not working, bad gearbox, and you are looking for easy gearbox fix, this video is for you, and especially if your gearbox is for Volkswagen Crafter 2.5 liter engine. There is videos on this channel when the whole engine getting rebuilt, so if you're interested in that, I will link in at the end of the video. But at the moment, what you'll see is that one of the main reasons why I was having problems with the gearbox, and the kind of problems I had was really stiff gears, and it was kind of knocking the gear out of a second gear all the time. And all of that problem is actually not because of a gearbox, but because of a linkage that is not working at all. It just seized up. It's a very poor design. There is a stainless steel pins that are fitted into the aluminium casing and into aluminium body, and there's also some very thin plastic bushes there as well. However, what you need to realize that when aluminium is actually gets corroded, it expands, it swells up, it creates like goes white powderish, and it swells up. So while it swells up, it just basically locks stainless steel pins inside, and the longer time you have, since the whole unit was new, the more stiffer the force will be and the harder it grips on the pins. So actually, as you can see, I couldn't even open it or close it with my hand, regardless how much strength I applied to that. So what I'm doing just now, I'm just basically spot welding the pins, because what I realized is the pins were so seized that they were actually turning within pin bracket. So I'm trying to weld these pins together so they don't spin in the bracket, and once it's all done, I'll be able to just trying to wiggle out and get those pins loosen out so I can disassemble the whole thing. Just the stainless steel pins, and it just the way, poor design. Stainless steel pins straight into aluminium with very thin bushes, and you'll be able to see nylon bushes. The thing with the nylon, with the time, it also absorbs like engineering plastics. They absorb certain amount of moisture, and they tend to swell up as well, which doesn't help. And simply because plastic cannot really withstand the stress, you can see how much white powder is on the stainless steel pin, and this pin was just sitting there seized solid. So here's a bracket just in the vices, and you can see it's really stiff, considering it's supposed to be totally free moving, and you can just see little nylon bushes inside of this aluminium hub, and inside of the hub the pin is exposed to any sort of dirt and so on. So I removed one of the pins, and you can even see that it's been snapped. It's been snapped long ago, because the surface is actually already corroded, and it changed the color. You can see it's not a brand new thing. So idea is to basically bore out existing bushes and machine new brass bushes for fitting into this bracket. So 9.5 mil, that's kind of diameter we have on inside, and then once I measure out outside, I can work out the thickness with bushes. So just hand drill, I can easily drill this out. However, what you need to bear in mind that when you're working with aluminium and you require some sort of lubrication, it's always helpful to have lubrication. The best lubrication you could have is very fine oil. That could be a kerosene, works really well, or if you don't have a kerosene, WD-40 or any like penetrating liquid will do a really good job. So just to show you, this is how you see how it progresses while it's dry, and if you use some sort of light oil like WD-40 or any other penetrant oil, it should go a lot smoother, a lot quicker, and you can see it on the type of swarf it produces while you're drilling through the aluminium. Naturally, I drill from one hole right through into another, so I still have same alignment in between two holes, because my pins need to be sitting in between two holes, and this axial alignment needs to be just needs to be there so the pins can function properly. Again, quite naturally, that here's a mark that when I was trying to extract a pin, I used just a heat from a burning gear, and basically overcooked it, made the flame far too hot, and something distracted me, and I simply just made a little damage, heat damage on the part. It's very easy done on aluminium, because when you work with aluminium and you're trying to heat it, aluminium doesn't change color with the temperature, so if you know, it's very easy to do that sort of things, but it's not really a problem in my case, because I can easily weld this up a little bit and just repair the damage without any questions. So as I said, this part is another segment of the arm, so I'm doing exactly the same thing. Obviously, if you're going to be welding aluminium, the cleaner it is, the better it will work, so give it a good brush up. It's not just fine enough for application, you know. There is no need to over exaggerate this sort of thing. So once it's welded up a little bit, you can brush it again just to tidy up, and it pretty much functionality remains as good as it needs to be. And now you can have a look at the little plastic bushes that sits inside, and you can see that they're extremely thin. So the second part, well, the arm also going to be drilled in the same way as you've seen before, right through, and have that continuity and alignment between two holes, so when pins join together, everything's going to be in the same line, in the same axis. And then I used had a small piece of bronze, small piece of bronze, and out of that small piece of bronze I made 4 bushes. It's fairly easy process, so don't need to concentrate on it a lot. The only issue is the wall becomes relatively thin, simply because I don't really have much body within the aluminium parts where this bronze bush is going to be sitting in. So it's kind of important that you do your math right and make sure you don't cut too much out of material. Just drill out a hole first, and once the hole been drilled, I just removed the rest of the material, and I didn't cut aggressively, so it was functioning really well. I was worried that if I may have wall too thin, it may collapse under a cutting process, but no, everything worked out fine. So it took me a minute to make 4 bushes, but overall I'm quite happy with the design, because with the result, because bronze, in difference to aluminium, will not swell up with corrosion, and therefore it will not grip on the pins in the future. So just checking my sizes. Once I'm happy enough with what I need to do, I'll part it off the tool, and that's going to be pretty much one. I am still learning how to use this video editing software, and without realizing, sometime the clips and segments left a little bit longer than I was intending to, but it's all part of a learning curve, I guess. So here I'm getting a little closer to the finished part of finished cut on this bush, and probably the next will be the parting off. You can see the type of swerve that produced while you cut in bronze, and this kind of swerve you don't really want to go into the machine, so it doesn't go into the coolant and then into the pump and causing all sorts of problems. So there is a little rug underneath the choke where all the swerves getting collected, and obviously you need to pay attention that this rug doesn't get wrapped onto the choke. So here's the one bracket with the bushes that were being fitted in, and here's another bracket. Unfortunately, when I was fitting the bush in, it just snapped right at that area. You can't really see that great on the video, but there is a small brown line right in the middle, which indicates like there is maybe like internal crack that was there for a little longer than just a time when I was trying to fit this bush. But again, that doesn't present much of a problem. Just little quick repair with the extra bracket on the back side, and that will be as strong as it needs to be for this application, especially considering that there was some space around and that piece of aluminum that I fitted in did not interfere. So I'm just seeing how it looks. That's how it's going to be positioned. The broken pin is obviously getting replaced. I just need to cut it off to size and weld it in place. So I kind of had to prepare my own grease. I had a little leftover from anti-friction additive to the oil. It was just left in the cup, so I used it on. Put some copper slip grease, just copper grease, and also I had in the storage for quite a long time. I had some graphite powder, so I'm adding graphite powder into it as well. So idea behind that, once I lubricate everything within inside of those bushes, even if the grease gets washed out or moved out with time, at least some graphite will still stay there, and it will act as a lubricant, especially considering that gearbox in the while it's in operating, a manual gearbox, it's actually getting heat up quite high. Some of them can run like 85-90 degrees, kind of similar to the temperature of the engine. And if you put just normal grease into there, there's a high chance that that grease will become liquefied with the temperature and simply just move out of all of this places where you put the grease in. But so what I'm hoping for at this stage, that within this gearbox, by the way, see this all linkages and little areas like this all been washed out with the brake fluid, cleaned up, and then greased again. So you can see how much difference in movement on this linkage there is. And when I'm making this video, the gearbox is been fitted on the van, and van after engine rebuild, it's done over 2,000 miles now, and there is a quite dramatic improvement within the gearbox, how it feels on the gear stick, that you can change gear without any problem, and especially the second gear that used to knock out of place, it is working fine just now. So if you guys interested to see the engine rebuild for this one, I will make the end screens for somewhere about this time in the video. Thanks for watching.